So the last lesson we talked about three measures of central tendency, and I did talk about extreme values a little bit in a list of numbers or in a list of data, which we're going to focus more on today. And a couple of you should be familiar with the name that we call extreme numbers. We refer to them as outliers. You've taken statistics. So you can see the first paragraph here, the scenario, you've got 11 people in a room. One person earns a salary of $1 million each year, and the other 10 earn teacher salaries, which are not $1 million a year. If you were asked to find the mean salary of the 11 people, would you think that value would be greater or less or equal to the salary of the teachers? You've got one person that makes $1 million. Let's say the teachers make $100,000 a year. So if you took the $1 million and then you added 10 $100,000s divided by 11, do you think that answer would be greater than 100,000 or less than 100,000? Greater than, right? Because that $1 million salary pulls it up. Okay, and that $1 million salary we would refer to as an extreme value because it's so different from the other numbers in the set. And when we talk about extreme values, the name that we give them are outliers. So for example, here's a smaller set of numbers. Five, 6, 9, 4, 7, then 52. Which one would you call the outline? 52. Obviously, because it's very different compared to the other ones. So this is the outline. And when we have outliers in a set of numbers or in a set of data, it can affect the mean, median, and mode, and does so in different ways. We saw just that example we talked about right at the beginning. The mean would get pulled above 100,000 a year, and yet 10 of the 11 numbers were 100,000. So as an example, here we have 10 house prices in the Charleswood area. And we want to find sort of the typical value of a house in Charleswood, or, you know, the center of all the values that we see, all the house values that we see. So three ways we can measure. We can find the mean, add them all up, divide by 10. Find the median, list them in order, smallest to largest. Find the two numbers in the middle, because it's an even set of numbers. Average them to get the median. And then the mode, we would just simply look for the value that appears the most often, if there is one. So the mean, and I'm not going to write all these, but suffice to say, we would have to go 255,900 plus 1,799,900 plus ... all the way to the end. $2,095 plus 331,700. Now this is a pretty lengthy example. You're not going to see anything this long, okay? Because it's quite a bit to do because the numbers are quite large. So we would have to add all those 10 numbers up, divide by 10, and I'll just simply give you the answer, because I'm assuming you can do it on your calculator. You get $474,510 for the mean. So that would be one measure of center. For the median, we'd have to do a lot of work again. We would have to take all these numbers and rearrange them from smallest to largest. Okay, which I'm going to go ahead and do that. So here they are. 2095 is the smallest. 255.9. 278.9. Then 284.9. 399.9. Please. No, I'm reading from the wrong list. That's right. 278, 284, 331. 331.7 is the next one. Then 364. 6. 389.9. 399. 429. What do you think there's so many that end like that? 429.9. Exactly. Yeah. Which is what retailers do, right? I mean, a lot of times you buy things for $199 or $7.99. And finally, the last one. So there's 10 numbers in the list. That means there's 2 numbers in the middle. So to find the 2 numbers in the middle, we go 10 divide 2, the 5th one, and the 6th one. So we have to count 1, 2, 3, 4, 5. This one's in the middle. So it's this one, 5th and 6th. And because there's 2 of them, to find the median, we would have to average the 2. So 331.7 plus 364.6 divided by 2 is going to give me a median value of 348.150. Quite different than the mean. Why do you think that is? Why are those 2 so different? What's happening here? Well, what's this lesson about? Right. Do you see one? Yeah. Yeah. Right. I mean, this one is really bringing the mean up. And yet it doesn't have as much of an impact on the median. Okay. So if there's one thing you want to remember between mean and median, like I said yesterday, okay, extremely high values will pull the mean up higher than the median. Extremely low values will pull the mean down below the median. And the third one, for mode, there is none. There is no mode, because all 10 values are different. We've already identified the outlier at 1,799,900. And we've really addressed this question too. Okay. Which measure of the 3 do you think would describe the typical house price? It would be the median, right? Because extreme values distort the mean. Because if you look at the median, or sorry, the mean, 474,510, that's higher than 9 out of the 10 house values. that doesn't really represent the typical value of a house. Okay? There are ways we can get around this. If we have a set of numbers that has an outlier or two in it, we can remove the outlier and calculate the mean. Okay? It is possible to do that. So if you deleted the outlier, the new mean, well, we do that 259.9, we take the whole list, except we wouldn't include the 1,799,900. So we're going to add 9 numbers. And then we get to the end of 2095. Plus 331.7. And remember, we're going to divide 9 because we removed the outlier. And when we do that, it's not that, 327. 27, 244, and 44.6. That's the mean. Now that seems to be more representative of the typical house value. If you removed it from the median, okay, and I'm not going to write this list all out again. So we would list them. I'm just going to go back to this. If we took this one out, how many values are in the list now? 9. Which one would be in the middle? The 5th one. 9 divided 2, round out. So this one, if we remove this, would be the new median. Okay. So it would be 331.7. 331.7. Notice the mean and median are a lot closer to each other now. And note, like, the mean really got affected when we took out the outlier and recalculated. The median, not so much. It moved just a little bit. And that's typically what happens when we have a set of data that has an outlier in it. Okay? So you can see here kind of a summary at the bottom of this page. And I've already talked about this. If there are more than one or more outliers in a set of numbers, a data set, they're strongly going to affect the mean. Okay? They'll have a slight effect on the median, but not very much. The mode, it really depends. Okay, I mean, it depends on what's in the original data set. And that sort of speaks to, again, as to why we don't really use the mode as a measure of central tendency. Okay. Okay. So here, Jennifer, Canadian Olympic athlete, participates in the women's mobile competition. It's judged based on turns, air, and speed. And they get a mark out of 5. Okay. And there are 5 judges that record their marks. And each one is out of 5. And what they do, okay, and they do this like in figure skating too, the highest and lowest marks are omitted. Okay. So I on the right page? No, I'm down too low, aren't I? Shoot. I'm gonna do this one. Mine keeps doing that. Anyway, sorry. Juanita received the following pledge amounts when she participated in the Air Cancer Rule. And you can see that she got 9 pledges. What measures of central tendency best represent the pledge amounts Juanita received? Well, really what you have to do when you're looking at the best of the 3 measures, look for outliers. Do you think there is one in this? Yeah, the 70. So 70 is an outlier. Therefore, the median would be the best measure. As soon as we have outliers, median's better. If there are no outliers, then really no difference between the mean and the median. Okay, now let's get to the second one. So justifying the removal of outliers. We saw in the example with the house values in Charleswood that removing that outlier, the mean and median became good measures of central tendency, both of them, if we remove that. Okay. So a lot of times what will happen, if the mean is used in a calculation, outliers will be removed. So here we have, and one of the places that it happened is in Olympic sports. Okay. So again, we're back to Jennifer, the mobile athlete. She was scored by 5 judges, and you can see the 5 scores out of 5 that she was given there. And we are told that the highest and lowest scores are omitted. So what's her score out of 15? Well, we would just simply eliminate the lowest, 3, and the highest, 5. So it would be 4.2 out of 5, plus 4.9 out of 5, plus 4.6 out of 5. Her mark out of 15, or her score, sorry, of 15, would be 13.7. Why do you think they do that in Olympic sports? Just to give you a little bit of additional information, the judges are from different countries. And a judge could possibly be from the country that there's an athlete participating. So one of these could have been a Canadian judge. Why do you think they removed the top and bottom? So there's no bias, exactly. Because one would think, and this is why figure skating is so controversial a lot of times, is, you know, you'll have like a Canadian and a Russian, say, that are the highest ranked, and then they perform their programs, and the judges, among the judges, are a Canadian and a Russian. Well, when the Canadian's up, they want to avoid the Canadian judge giving a high mark and the Russian judge giving a low mark to favor his or her athlete. Okay, so that's why they eliminate top and bottom scores. So yes, I mean, really, to reduce bias. And just as an example, a Canadian judge may score a Canadian athlete. Higher. Whereas a judge from a competing nation may score lower on purpose. So they want to avoid that. I think they do that in diving too. I think they do that in gymnastics as well. It's always been an issue in Olympic sports. Ones that are judged. Okay. Last thing we'll look at, something called the trimmed mean, which basically we're going to trim the data set so that the mean is a more accurate representation of the center of a set of data. Okay. And why the mean? Because the mean is the one most affected by outliers. So often what will happen, okay, is we calculate it in the same way that we do the ordinary mean. However, a certain percentage of the extreme values are omitted. Different percentages may be used. So they may say, take 20% of the numbers that are outliers and trim them off. Okay? Or they may 10%. And when they say 20 or 10%, that means what you got to do is you got to go to the lowest. Like if it's 10% trim mean, you take the lowest 5% and the highest 5%. If it's a 20% trim mean, you take the lowest 10% off and the highest 10% off. So as an example, okay, this guy is collecting, this manager is collecting how many snowboards were rented during 20 Saturdays of winter. And we can see the 20 numbers here. We want to calculate the 10% trim mean. That means we've got to take off 5%, okay? So 5% of 20. And this is for the low. Is 0.05 times 20, which is 1, which means we're going to remove one low. For the high, we're going to remove 5% of 20, which obviously is also 1. So remove one high, or remove one low and one high. And then find the mean of what's left. So there'd be 18 left. So we need to find the lowest in here. And it looks like the lowest is 32. So we would strike that one off. And then we need to find the highest. And it looks like the highest is 156. Yeah. So we take those off. We trim those off. Find the mean of the remaining ones. So we would have to do 100 plus 99 plus 87 plus etc. 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 all the way to the end of the list plus 82 plus 894 and divide by how many again? Remember we've trimmed 2. 18. Yeah. Watch out for that. Don't write 20 as we've trimmed 2 of them off. And when you do that, you're going to get above 87.3. So the trim mean will work if there's a few outliers. Okay? If there's a lot of outliers, the trim mean isn't going to make that much of a difference. So you really got to look at your set of numbers to determine, would a trim mean give me a good representation of the center? Okay. So from this lesson, how outliers have an effect, big effect on mean, little effect on median, mode, it's kind of depends, right? And then we talked about how to calculate a new type of mean called the trim mean. Okay.